So welcome, this is part 5 of multiple choice questions for chemistry, paper 2, IGCSE 0620, the most predicted paper. So we have done part 1, part 2, part 3 and part 4, and we have covered up to 64 questions. Now we are starting from 65 questions, 65th question in part 5. So this is question number 65 from March 2019, paper 22, question number 21. Which statement describes the chemical property of aluminum oxide? So basically it is going to be an amphoteric oxide, in the sense it will react with both bases and acids. So obviously there it reacts with acid but not bases is wrong. It reacts with bases but not acids is also wrong. And it never reacts with water. That is also, it reacts with water. No, it never reacts with water. So being an amphoteric, it reacts with both acids and bases. So option 2 is going to be the correct answer. Coming to the next question, question number 66. What does it say? The equations of three reactions are shown. Which reactions are suitable for making salt by precipitation? By precipitation means, what is the thing is, basically precipitation reaction reacts with two soluble solutions and we get a solid, and then what is this? A soluble solution, aqueous solution. So two solutions should be aqueous and the product should have a solid and an aqueous. So we can see that first option is having aqueous, aqueous and a solid and aqueous. So for first option can be correct. Second option is also having aqueous, aqueous and an aqueous and a solid, yes. And the third option, we can see that solid and aqueous. So this is only wrong, and moreover there is no precipitate at all. Both is aqueous and liquid. So third option is going to be wrong option. So third option is wrong. We are left to only 1 and 2. So B is wrong, C is wrong, D is wrong. So answer only, what is this? Option A is going to be the correct. Following substances can be reacted together to prepare salts. Which reactions can the excess reactant be separated by the process of filtration? So in the first one, what's happening in the first one is we are taking copper oxide plus we are taking H2SO4. Copper oxide plus H2SO4 and trying to, what is it, we will be having, what will be forming it out? We will be forming copper sulfate plus water. So what is happening is we are using this sulfuric acid in excess. We are using sulfuric acid in excess. So therefore what is going to be, not, it is in the form of aqueous one. So the entire copper oxide is being dissolved and everything is converted into copper sulfate. So nothing is going to be, what is this, present in the form of a crystals or something which can be filtered. So therefore filtration process is not possible for the first one. Whereas for the second one, what happened to the second one? We are adding HCl plus NaOH, sodium hydroxide, gives rise to NaCl plus again H2O. Now again, what is this? NaCl is going to be aqueous and we are again giving excess of sodium hydroxide. Excess of sodium hydroxide means nothing but what? The entire hydrochloric acid is being used and the remaining excess sodium hydroxide is again what is in the form of a dissolved substance. It will not be in the form of a, what is this, a solid. So therefore we cannot remove this excess sodium hydroxide also. Whereas hydrochloric acid plus zinc carbonate. So what happens to hydrochloric acid and zinc carbonate? When I take this hydrochloric acid and zinc carbonate, so it will form ZnCl2 and we are using excess of zinc carbonate, means entire hydrochloric acid has been used and it will form ZnCl2. So the remaining Zn carbonate or zinc carbonate will be left over because we are using, what is this, excess. So some part of zinc carbonate will be using the hydrochloric acid and the hydrochloric acid is totally used. So nothing is left over. So excess of zinc carbonate will be remaining as crystals over here, which can be which can be removed by filtration. So option 3 is only the answer. So which is nothing but what? Option D. Coming to the next question, question number 68. 5 steps in an acid-base titration are shown. Which is the correct order? So first of all, whatever we are doing it out in an acid-base titration, we take a conical flask and what is this? We'll be adding it a base over here. So first base or an acid. If acid is added, we'll slowly add the base. If base is taken, we'll be slowly adding the acid. So first step is nothing but what? We take the, what is this? A volumetric pipette and add a fixed volume of alkali. So 3 is going to be the first option. So first step is going to be 3. So obviously, what is this? D and A are wrong. Now The next one is nothing but what, once we are there, we will be, because all the bases are colorless, we will be adding an indicator over here. So we have to add an indicator, which is the indicator 2. So therefore, the second option is going to be 3, 2. So obviously, this C is also wrong, but then also we'll check it out. So then after that, what are we going to do it out? We are going to record the initial volume of the acid. So slowly, what we will do it out is, we will add the acid drop by drop. So drop by drop, we'll add the acid. So for that, we will be, what is this, measuring the initial volume. Then we will be slowly adding it out. So this is 1, and finally we will be taking the final volume. So 32415, option B is going to be the answer. So I first take a conical flask with a big base and then add the indicator, then add the, what is this, find the initial volume of the acid, then slowly add drop by drop of the acid, and then final volume of the acid has to be noted. So 32415 is going to be the answer. Coming to the next question, question number 69 from June 2020, paper 21, question 18. The graph shows how the pH of a solution changes as an acid is added to an alkali. So at the starting, we are starting with 14 and then acid is added. Slowly as the acid being added, we can see that the pH value keeps on decreasing. At a certain point, it becomes neutral. Now, but we are not stopping the acid. So we are keeping on adding the acid. So therefore, it becomes a strong acid. After neutralization, we still continue to add acid. So the total whole solution becomes an acidic solution. So what is he telling it out over here? Which letter represents the graph where both acid and salt are present? So obviously we know that at A only alkali is present. At B we are adding the acid and slowly the neutralization reactions takes place. At C the total neutralization has been done, so we'll be having only the salt. But what is happening? I want salt and an acid. So from here we are keep on adding the acid. So over here at D we can see that it will be having a, what is this, a pH which is less than nothing but what, 7. Why it is less than 7? Because when I take salt and an acid, we know that acid will, salt will be having a pH of 7 and acid will be having a pH of less than 7. So obviously there will be a region where there is less than 7. That region is going to be where both acid and salt are present. So answer is going to be D. So D is the answer for this question. Coming to the next question, question number 70 from March 2020, paper 21, question number 22. A salt S is dissolved in water and 3 tests are carried out on the solution. So first one is aqueous sodium hydroxide is added and we'll get a green precipitate. Green precipitate means it can be either be, what is this, Fe plus 2 or chromium plus 3. So but which one has to be there out of this? The next one will tell insoluble in excess. So Fe plus 2 is insoluble, whereas chromium is going to be soluble in excess. So therefore it has to be iron. So when I know that it has to be iron, so my first option is wrong and second option is also wrong. So answer has to be either third or fourth. Next one, what else he says? Dilute nitric acid is added and no reaction. No nitric acid is reacted. Nitric acid is not getting reacted means nothing but what? There is no carbonate ion. There is no carbonate ion. Then finally, when we, after adding the acid, we are adding so barium nitrate, and is, what is this, to the solution in test 2, white precipitate is formed. So barium nitrate, barium has a property that it will be reacting with the sulfate ions and it will form BaSO4. So therefore, this YPPT is because of nothing but what, sulfate ions. And we have iron. So iron and sulfate ions is going to be nothing but what, option, what is this, D. So therefore, because barium will form a white precipitate with sulfate ions, so we know that it was sulfate and iron because of green color and so insoluble in excess. So iron and sulfate will become iron to sulfate. That's going to be the answer. Next, question number 71 from November 2020, paper 23, question number 20. Period 3 of the periodic table starts from sodium to argon. So we have sodium, magnesium, aluminum, and so on till argon. Element Q is a non-metal. So obviously the element Q is over here. Which statement of Q is correct? It conducts electricity? No, non-metal do not conduct electricity. So therefore, the first option is wrong. Only metals do conduct electricity. It has a lower proton number than sodium because the group is only starting, the period is only starting with sodium, which is 11. So what is the thing is, below 11, nothing else is there. It has to go back to the second period. So therefore, but it is in third period. So it cannot be less than 11. So what is this? B option is also wrong. It has electrons only in the third shell because it is a period 3, right? So obviously it has to be third shell only. So all the elements will be having the electrons only in the nothing but what? Third shell. So therefore option C is correct. It is malleable? No, it is not malleable. Malleable are nothing but what? Metals are malleable, whereas non-metals are not malleable because they are brittle and they can be broken easily. So, but metals are malleable means they can be bent into any shape. So, therefore, option D is also wrong because it is a non-metal. It's not a metal. So, answer is going to be only C. Coming to the next question, question number 72 from specimen paper, paper 23, question number 2020. Magnesium, calcium, strontium, and barium are group 2 elements. Group 2 elements follow the same trends as that of the group 1. So, in group 1, what are the elements we have? We have lithium, sodium, potassium, rubidium, and cesium. So, what is happening as we are going down the group? What will happen is the reactivity increases. Reactivity increases because we are going down the group, the reactivity will be keeping on increasing. So he says that the second group elements also follow the same that of the first group. So what are those elements? Magnesium, calcium, strontium, and nothing but what? Barium. So therefore reactivity over here also increases down the group. What is he asking? Calcium reacts faster than the magnesium. We can clearly see that calcium reacts faster than the magnesium. Yes, calcium is reacting faster than the magnesium. As you go down, the reactivity increases. So therefore, option 1 can be correct. Barium reacts less vigorously than calcium. No, barium is more reactive than nothing but what? Magnesium. So therefore, second option is going to be wrong. And third option, strontium oxidizes in air more slowly than barium. Yes, strontium is less reactive than barium. So therefore, option 3 is also correct. So option 2 is wrong. So wherever option 2 is there, that is going to be wrong. So option is only 1 and 3, which is correct. That's going to be the answer. Coming to question number 73 from June 2019, paper 22, question number 21. The melting points and boiling points of the elements of group 1 of the periodic table are shown. Which of the elements is a liquid at 800? So we know that before melting point, it is going to be nothing but what? The substance will be in the form of solid. Between melting point and boiling point, the substance will be in the form of a liquid, and after boiling point, the substance will be in the form of a gas. So we have to see it out that which one is there at the substance which is liquid at what is this 800 degrees Celsius. So we'll take lithium. So we can see that 800 is there between 181 and 1330, so therefore it is a liquid. Sodium 98 and 883, so 800 is there in between 98 and 883, so therefore it still will be a what is this liquid. Then potassium and what is this potassium over here, 800 is over here, means above 800 we know that it's going to be a gas. So potassium is going to be a gas. Rubidium over here 688, again 800 is a, what it says the temperature given, so it will be gas. And finally cesium, for cesium also the temperature given is 800, therefore it also is going to be gas. So only the action what is this or only the option is nothing but what? Lithium and sodium, so which is nothing but what? Option C. And option A, B, D are wrong because they are not what is this liquids at that particular temperature. So answer is C. Coming to the next question, question number 74 from March 2019. This is 2019, paper 22, question number 25. So let us start. Acetylene is below the iodine in group 7. So in group 7, acetylene is below the iodine. So let us write it out all the elements in this group 7. What are the elements in the group 7? Fluorine, chlorine, bromine, iodine, and acetylene. So now what is the thing is, we know that the first two one is going to be nothing but what? Gas, and the bromine is going to be nothing but what? Liquid, and what it says the remaining two will be nothing but what? A solid. So what is the thing? We came to know that nothing but what? The properties of acetylene. So properties of acetylene, we came to know that it is a solid, so therefore the part A is wrong and part B is also wrong. Now among from part C and D. So what is the thing is, acetylene is very least reactive, so it cannot what is this displace chlorine, bromine, or iodine because it is very least reactive. So therefore option is going to be nothing but what? Option D is correct, and C is also nothing but what? Wrong. So that's going to be the answer. So now coming to the question number 75, he says which metal has a variable oxidation state? Oxidation state should be variable. So aluminium will be having an oxidation state of +3, calcium will be having an oxidation state of +2, whereas sodium will be having an oxidation state of nothing but what? +1. So we can see that copper is only the transition element. So therefore, aluminium, calcium, and sodium are the wrong options. So answer is going to be the copper, which is a transition metal. So transition metals only will be having what is this? Variable oxidation states like Cu plus 1, comma, Cu plus 2, and so on.